In this reaction, we have nitrogen reacting with hydrogen to produce ammonia. Here's your balance equation, which really tells you the ratio or the proportions in which these reactants are combining to produce our product. We're taking 3 moles of nitrogen and 6 moles of hydrogen and putting them into a container. And we're first going to solve this using pictures, or what we call particle diagrams. You're going to place 3 moles of nitrogen, remember it's diatomic, and 6 moles of hydrogen gas into this container. So 6 copies of H2. And we're going to start circling sets and see how many sets of NH3 or sets of product that we can make. Look at your balance equation. For every 1 nitrogen, exactly 3 hydrogens are needed. So in our sets, we always have to circle 1 nitrogen and 3 hydrogens together. Every time that they combine, they produce product. Looking at our balance equation, specifically 2 moles of product. So I circled, every time I circle, I write 2 copies of NH3 because its coefficient is 2. I'm going to keep going until I can't go anymore. 1 nitrogen and 3 hydrogens. There's another set. And again, that makes 2 copies of NH3. I can't keep going because I have no more hydrogens, and I just have that extra N2 floating in the container. Looking at our picture, count the number of moles of ammonia made. 1, 2, 3, 4. The limiting reactant is the one that completely runs out, the one that is completely used, the one you don't have any more left of, and that's going to be the hydrogen. Your excess reactant is going to be nitrogen, and specifically you have 1 mole of nitrogen left in the container. Well, what if I didn't have a picture? You would have to solve this using a BCA method. First step, rewrite your balance equation. You have nitrogen reacting with 3 hydrogens to make 2 ammonias. So before the reaction goes, we're going to write down the quantities that we have. Looking at the given values, they told me we have 3 moles of nitrogen and 6 moles of hydrogen. So 3 and 6, and we always start with 0 NH3s, or 0 products. For the change, you don't know which one the limiting reactant is because let's assume we didn't draw this picture and we didn't know the limiting reactant. You need to test the first one. If nitrogen was limiting, then we would know that we're going to subtract all 3 of it because all of it is used. And that limiting value gets copied to all the other columns. Reactants get minus signs, products plus signs, and we multiply by a fraction. It is the coefficient of where you are, in this case the hydrogen, 3, over the coefficient of the limiting. So hydrogen is 3. Nitrogen is your limiting reactant. For right now, that's what we're saying. Assume nitrogen is limiting. Its coefficient is a 1. So it's going to be 3 over 1 for the hydrogen column. 3 times 3 is 9. Pause, evaluate, and see if you can continue going on with this as your limiting reactant. You have 6 moles of hydrogen available at the beginning. 9 moles would be required to react with all of our nitrogen. When the change is bigger than the before, it doesn't work. That means you don't have enough hydrogen. Hydrogen, therefore, is going to be your limiting reactant. So since this doesn't work, I stop. Don't continue with this change row. I want you to create a new change row, cross out this old one. We're not going to look at it anymore. So if nitrogen can't be the limiting, then we're going to test the hydrogen. Hydrogen should be the limiting reactant here. But let's make sure it works. For our change row, since hydrogen is now your limiting, we're going to subtract all of it. So that value 6 gets copied to all the other change boxes. Reactants get minuses, products plus signs. And then we multiply by that fraction. Nitrogen's coefficient is 1. Now your limiting reactant we're saying is hydrogen. Its coefficient is 3. So denominator of 3. You're going to repeat that for the ammonia. Its coefficient is 2 over coefficient of hydrogen of 3. We're going to simplify in each one of our change boxes. 6 over 3 is 2. So you see here that nitrogen, yeah, you have enough nitrogen. 3 at the beginning, 2 are needed. You have enough. So yes, hydrogen is that limiting reactant. For the ammonia, 6 times 2 is 12. Then 12 divided by 3 is 4. So your after row is the combination of before and change. Nitrogen starts as 3. We're minusing 2. You're going to end up with 1 mole of nitrogen left over in excess. The hydrogen should be 0. 6 minus 6. And then the ammonia, 0 plus 4. We're going to end up making 4 moles of ammonia. So again, highlight that limiting column. A few things to note. The limiting is the 0 at the end of the reaction. Its coefficient of 3 gets copied to the denominator of all the mole ratio fractions. And its used value of 6 is copied to all the other change values. So reading our BCA table, how many moles of ammonia gas are produced? Go to your after, go to your product. 4 moles of ammonia are made. Your limiting reactant is hydrogen. Your excess reactant is nitrogen. And according to your BCA table, 1 mole of nitrogen remains after the reaction. 1 mole of nitrogen does not react. And if we were to compare this to our picture from above, this is exactly what our picture is showing us. We made 4 moles of ammonia, 1 mole of nitrogen remains, and all of the hydrogen is completely used. So therefore, that hydrogen is the limiting reactant. Finally, here in part C, how many liters of NH3 are produced at STP for this reaction mixture? STP stands for standard temperature and pressure, specifically 0 degrees Celsius and 1 atm of pressure. We can use the conversion factor of 1 mole equals 22.4 liters anytime you need to convert between moles and liters of a gas that is at STP conditions. So we want to solve for liters of NH3 that are produced. How much is made? We'll look at your BCA table. How much is made of ammonia? We're making 4 moles of ammonia. So if we have 4 moles of ammonia, we can convert that into liters using this conversion factor from our mole map. For every 22.4 liters, there are 1 mole of NH3. So moles of NH3 cancel, and you're left with liters of NH3 in that numerator. And you stop and you calculate 4 times 22.4. You get 89.6 liters of NH3 ammonia. And finally, sig figs, you go back to that given value all the way back to the very top. There are 3 moles of nitrogen, 6 moles of hydrogen. Each one of those only has 1 sig fig. So I want to round my answer to 1 significant digit. So I need to keep that 8, but there's a 9 behind it. So this rounds up to 90 liters of NH3. And that is 1 significant figure. That 0 at the end does not count because there is no decimal point.